Hello guys, this is a new video on chapter 11 which is based on 3-dimension geometry, So before doing it, we will be doing some basics about the 3-dimension. So as we all know what is 2-dimension. Now in 2-dimension we have an x-axis, we have an y-axis. So x is the one dimension and y is the other dimension. That's why it is 2-dimension. Now if you see a figure in 2-dimension, this rectangle which I have drawn, see there is length, there is breadth, and there is no height. So we have only 2 dimensions here. That's why it is called a 2-dimensional axis. Okay, now you can see that these two axes are mutually perpendicular to each other. You can see this is 90 degree, this is 90 degree, this is 90 degree, and this is 90 degree. So all are perpendicular to each other. Okay, so you can see two mutually perpendicular axes called xy axis. Okay, now let's talk about equation of the x-axis and y-axis. When you're finding the equation of x-axis, this one, just think from where it is passing. Look at the y-axis and tell me from where it is passing. It is passing from y equals to 0. Suppose if I say y equals to 1. So if I say y equals to 0, okay, look at the x-axis, from where it is passing. It's passing from y equals to 0. And if I say y equals to 1, so here is the point 1, y equals to 1, this point if I want to find, this line if I want to find, I'll be passing a line from here. Okay, so similarly for this x-axis, I'll be passing this line from where? Y equals to 0. So that is the equation of our x-axis. Similarly, if you want to find the equation of y-axis, look at y-axis from where it is passing on x-axis. This is passing from 0, 0.0, this is passing from here, 0.0. So that's why the equation will be x equals to 0. Okay, now let's proceed to 3-dimension. Now you can see the figure should be clear to you. Okay, so you look at this point, I have an x-axis, I have y-axis, and I have height. Now the 3rd dimension has come. That's why it is called 3-dimension. Previously I was drawing like this. Now I will be having height. Like this I will be having height. Okay, so let's talk about this point. Now to reach this point, how I need to move along the coordinate axis. So see, the first coordinate is A. So now you can see you have to move A in this direction because it's the x-axis. Then you have to move B in this direction. Okay, see, I'm moving along this direction, but I have to move from here. Starting from here, I have to move in this direction. Okay, I cannot move along y-axis. I have to move in this plane here. So I have moved B in this direction. then I have to move C in this direction, then I will reach to this point. Understand? First I'll move in this direction, then I'll move in this direction, then I'll move in this direction to reach this point. So that is how we represent points on 3 dimension. Okay, so now you can see 3 mutually perpendicular axes are called XYZ axis. Okay, now let's talk about the equation of, not the lines, now we will be talking about planes, but before that I want to show you a model. Now look at this. This is our 3 dimension. This is a 3 dimension. One plane is like this, okay, or you can consider 3 planes. This big plane, this big plane, and this one, this big plane, they are cutting each other to make a 3-dimensional space. Okay, these are 3 planes cutting each other to make 3-dimensional space. Okay, now let's look at only this. Look at this point. This is our point. So to reach this, I have to move along X direction like this, I have to move in Y direction like this, and I have to move in Z direction like this to reach this point. Okay, and this is called our first octant. Octant. Why octant? You can clearly see that these planes, when they cut each other, they are making rooms. They are making rooms. You can see this is our first room. Behind this there will be one room. Okay, here will be one room. Okay, and this will be one room. So we have 4 rooms here. Below also we have rooms. So now you can see this is one room. Behind this there will be one room. On the other side, that side, there will be one room, and here will be one room. So total we have 8 rooms. These 8 rooms are called octants. Okay, and this is our line. Previously it was vector in Vectors chapter. Now we are considering it as line. Okay, and remember, this line can be extended on the other side also, like this. Now that was the model. Now you can see that plane exactly here. This is one plane, this is another plane, and this is another plane. Okay, and this line which I extended, this goes to the other side. This will make other chambers, octants. Okay, so like behind this there will be one, there will be one, and here will be one, like that. Now let's talk about the equation of the plane xy, yz plane, and zx plane. Okay, sorry, I have written axis here. This should be plane. Okay, now equation of xy plane. Now when you are talking about that, when you are talking about xy plane, look at xy plane. This is our z-axis, and our xy plane is passing from that. So to get this plane, we need to pass from z equals to 0. Okay, so that's why the equation of the plane will be z equals to 0 for xy. Similarly, if you look at yz plane, okay, yz plane, this plane is passing from this line. This is our x-axis. So yz plane, the equation will be x equals to 0. Similarly, xz plane. Now try guessing the equation of xz plane. Xz plane is passing from this line. This line is y. So that is y equals to 0. So that is how we will get the equation of our xy plane, yz plane and zx plane. So these are basics about 3 dimension. We will be talking more just roughly. Roughly you should know what is the equation of xy plane, what is the equation of yz plane, what is the equation of zx plane. Xy, z equals to 0, yz, x equals to 0, zx, y equals to 0. So you can find the pattern to remember this. Now let's talk about basic formulas. Okay, so first one is distance formula. Now distance formula, it's the same like we did in class 10. Here only the difference is one point has been increased. Previously we had xy axis, so we had xy point. Here we have z axis also, so our point becomes x, y and z, and you can clearly see that same formula, but this term has increased. So I don't need to explain, you know this formula. Now let's go to section formula. Now section formula. Why do we use section formula? To find a point which divides the join of 2 points in the ratio m is to n. Okay, and there are two cases. One is internally and external division. So if you want the proof, I'll be making another video for section formula proof. Okay, how plus comes and how minus comes. Okay, so here you can clearly understand that this point is dividing the line, but here in external it is a little difficult to understand. Let's go one by one. Okay, previously in class 10 section formula you did internal only. So what did you do? M into x1 or m into x2 plus n into x1 divided by m plus n. That is how you find. You can see clearly all the formulas from class 10, only we increase it for z. Now externally means the length are in the ratio of m is to n. The lengths are in the ratio of m is to n. You can clearly see that AB, this is the distance AB. Okay, so an external point, how can it divide? Okay, so here you don't think like it divides, just think that the ratio of that point from A is m, and the ratio of the distance from B to C is n. Okay, so think like that, it will be easier to understand. The ratio of the distance, 1 is to 2, 2 is to 3. So if this is 6, this may be 2. So what is the ratio? 1 is to 3. They're dividing it in the ratio 1 is to 3. Okay, if this is m is 10, this is 5, n is 5, so that will be 1 is to 2. Think like that. The ratio is only this m and n are only the ratio of the distances of the point from the point A and B. Think like that. Don't think as it divides. Okay, we say it divides, but don't think like that, it will be confusing. It's simple that the distance ratios are m and n. From A to the point is m, from B to the point is n. Okay, so that is how. And in this case externally we just put a minus sign in the numerator as well as denominator, you will get the answer. Now let's see centroid. You know what is centroid? If I have a triangle, I draw three medians, and the point where the three intersects, that is called the centroid. So if you are asked to find this point centroid, you will be using this x1, x2, x3, add them, divide by 3, y1, y2, y3, add them, divide by 3, z1, z2, z3, divide by 3, you will get these points, this point. So that is called the centroid. Okay, remember it should be drawn with the median. Median only will make a centroid. So all three will be median. That means equally dividing the other side. Okay, you don't need to draw, just understand this. Okay, now let's come to the actual thing in 3D. So first thing we'll be talking about direction ratios and direction cosines of a line. Okay, so here I have missed ratios, so you put direction ratios here, direction cosines and direction ratios of a line. Now it is same as vectors, but till now we don't know the how do we find the equation of a line. So we will be only talking about the direction ratios. So now look at the line, this line. Okay, this line, previously it was a vector for us. Okay, now there is a line. So now let's talk about the direction cosines. So previously also we know that if the line is making, if there was a vector, so here line, if that line is making an angle alpha with the x-axis, beta with the y-axis, and gamma with the z-axis, you can see those angles. You can see those angles. Then cos of these angles will be called the direction cosines. Okay, and cos of these angles will be called direction cosines. Now you see this line L, it is extended on the other side also. Okay, other than this axis, it is extended to the other side also. Now if I say this angle is alpha, and this line is making a 180 degree, so obviously this angle will be 180 minus alpha. Okay, now you can see this line, don't get confused, just see the line nicely, that this angle is alpha, so this angle will be pi minus alpha. Okay, now you see that line, if this is the line, it's making alpha angle here, beta angle here, and gamma angle here. This is alpha, this is beta, and this is gamma. Okay, now when I extend this line, it will go to our, if I extend this line, it will not come to this quadrant, it will come to that, it will not come to this octant, it will come to that other octant which is behind this. Okay, so it will be making angle with 7th octant. Okay, 7th octant. How 7th octant? Let's revise octant here. The first octant. Okay, behind this is 2nd octant. Here this is 3rd octant. This is 4th octant. Go in anti-clockwise direction. Now similarly you come down, come below 1st octant. This will be your 5th octant, 6th octant, 7th octant, and this is 8th octant. Okay, so this is how you will remember anti-clockwise, starting from the positive, all positive quadrant. This diagram is clear, I think. If I extend the line, it will be going to the 7th octant. Okay, if this is in the 1st octant, the extended line, this one, will be in the 7th octant. So there the angle which it will make will be pi minus alpha, pi minus beta, and pi minus gamma, like that. Okay, now I have clearly written here you can see alpha, beta, gamma are direction angles, and if I take their cos, they will be the direction cosines of the directed line. Now if we reverse the line, similarly which I said before, that if I extend the line on the 7th octant, the angle will become pi minus alpha, pi minus beta, pi minus gamma. So when I take their cos, I hope you know from class 11, from class 10, cos of pi minus alpha will be cos alpha, and then this falls in the second quadrant. Okay, there is this pi means 290s, so even number of 90s, so cos will not change, cos will remain cos. Okay, but which quadrant? Pi minus alpha is second quadrant, so cos is lying in the second quadrant. Cos second quadrant is the house for sine and cosec, so this will be negative. So similarly I have put negative sine. So similarly for cos pi minus beta and cos pi minus gamma, we will get minus cos alpha, minus cos beta, and minus cos gamma. So you can clearly see that previously we had cos alpha, cos beta, and cos gamma as the direction cosines. Now we are getting direction cosines as minus cos alpha, minus cos beta, and minus cos gamma for the same line. Okay, so for a line, direction cosines can be positive as well as negative, you can see. So the direction cosines can be positive as well as negative for a line. So now, for a line, now you need to understand this very nicely. Any three numbers which are proportional to the direction cosines of a line are called direction ratios of the line. You look here, A is lambda times of L, that is called proportional, or you can say A by L is equals to lambda, some value I will. A is 25, this I can write, suppose A is 25, I can write 5 times 5. Okay, so they are related like this, see, A and L. That means A will be some lambda times of L. So if you have any line, you find their direction ratios and direction cosines, you can find a relation that direction ratio is some lambda times of the direction cosines. Understand? Suppose that, again, let's have an example again. If A is 27, okay, and L is suppose 3, okay, so there is a proportion, so A is proportional to L, or I can say direction ratio is proportional to direction cosine. Yes, because I can say 27 by 3 is equals to 9. Okay, so they are proportional. Okay, that is 9:1. Okay, it will take a little time to understand, but know that direction ratios and direction cosines are proportional. That means one will be a factor of another. It can be in points, it can be in integral value, it can be decimal value. Okay, so don't need to worry. And this is not exactly the definition, this is the relation between direction cosines and direction ratios. Okay, direction cosines we already found out how to find. Okay, direction ratios will be given to us, or we will find from the line. Okay, this is the relation between direction cosines and direction ratios, that direction ratios will be some scalar multiple of direction cosines, or we can say that direction ratios are proportional to direction cosines. Okay, so by that statement proportional, I can write that A and L are in proportional, that I can write them in ratios. Okay, so A by L is equals to lambda, B by M is equals to lambda, C by N is equals to lambda. This is from 1. Now once I have written this, all are equal to lambda. So if all are equal to lambda, then I can write all are equal to lambda. So I have written equal. Now what do I do? I reverse them. L by A is equals to M by B, and by c equals to 1 by lambda, and 1 by lambda I take it as k. It's just to make a relation. I want to find the value of k, so for that only I'm doing this. Okay, not a big deal. So L equals to, now I am equating this one and k. So L equals to k times A. Equate this one to this, M equals to k times B. Equate this to this, I will have N equals to k times C. Now you can see, we know that from vectors also. I have told you this relation about the direction cosines. Now whenever you find the direction cosines of a line, square all the three and add them, you will get 1. So in place of L, M and L square, M square and N square, I have put this. So when you try solving in the copy, when you copy down notes, so you will get k equals to plus minus square root of this. Okay, so where we are heading with this is, you can see now our L was k times A, M was k times B, and N was k times C. So now see here, L is equals to k times A. So k, I got the value, so I substitute here, I get this. K B, k I got the value, substitute, I get this. K C, I get this. Okay, so these are the direction cosines. This can be written as cos alpha, cos beta, cos gamma. Okay, they are also called as this. Okay, now let's see direction cosines of a line passing through 2 points. Okay, we previously did direction cosines, but we didn't talk about direction ratios. We assume that direction ratios will be, we are not assuming, but direction ratios will be given, and direction ratios, if not given, the points will be given. From there we'll be able to find the direction ratios. Remember, in vectors, how do we find the direction ratios? x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. Similarly here we will be doing, but this is a line, not vector, so we will not be using I cap, j cap and k cap. Okay, don't get confused. In line we will not be using I cap, j cap and k cap. Here we will be using only the direction ratios. So if the line is passing through 2 points, this, so the direction ratio same as vectors, I will be finding x2 minus x1, y2 minus y1, z2 minus z1. So if the points are given, it is very easy to find. And the distance between this PQ, distance formula, I can find the distance between these two, PQ. So how do we find? This is the distance formula we will be using and then finding it. So once you have found the distance between PQ, how to recall, how did we find in vectors? We did a1 by square root of a1 square plus b1 square plus c1 square. What was this quantity? This was the magnitude of the vector. Similarly here we will divide by the length. So you can see this direction cosines now. So you can see cos alpha can be written as, this is the direction cosine, a direction ratio, see here, divided by the magnitude. Okay, divided by the magnitude. So similarly here for cos beta, I will be using, in vectors we use b1, so here we'll be using the second direction ratio divided by the magnitude of the length. Okay, this is the length, PQ length. Okay, now cos alpha similarly will be using the third direction ratio and divided by PQ. I think you understand this much because vectors also you have done, so you should be familiar, you must not have forgotten. Now the heading for this you can write as collinearity. Okay, so the heading for this is collinearity. Now, collinearity. Now in class 10 we have done that two lines are parallel. If two lines are parallel, then a1 by a2 equals to b1 by b2 equals to c1 by c2. That is the condition for parallel. Here also we'll be having the same thing. Okay, but what we will do is whenever they are asking collinearity, we'll be asked about 3 points. Two lines, I want to prove them parallel, so I need to satisfy this condition. Now if I say there is one point common, that means B is common in both. B is common in both the lines. That means they are not parallel, they are like this: A, B and C. Okay, so here we will be using, to show collinear, we will be using this here. To show collinear we'll be using this, but we will check if they have a common point or not. If they have a common point, then we will say collinear, otherwise they are parallel. And in vectors also we did see, let's recall, for collinearity we proved A is lambda times of B, or B is lambda times of A. Okay, we can prove by this also, and we can prove by this also. Okay, this will prove parallel, the two vectors are parallel. Okay, and this will prove the collinearity, so you should not be confused. Okay, here we will be in lines, we will be proving this, as well as we will show one point is common. Now with this, let's start the exercise. Okay, angle between, this is very important. In vectors also we did angle between two lines, so it was very simple, and a1 a2 a1 b1 and c1, a2 b2 c2 was given. Here also two lines are given, their direction ratios are given. These are the direction ratios of the lines. So what we will do, it's simple, we can use the vector idea to find the formula, so that's why I'm not doing it. So cos theta is a1 a2 plus b1 b2 plus c1 c2, and divided by square root of a1 square plus b1 square plus c1 square, and square root of a2 square plus b2 square plus c2 square. That is how we'll be finding the angle between two lines. So don't get confused, it's very easy. These are the basics of 3D2. If you want to proceed further, these things should be in your hands. Okay, you should not be confused about anything. If you have confusion, try watching it again, and then if you have any problem, you ask in the comment section. Now let's start the exercise. Exercise is not that difficult, it's very easy. I request all of you to take the book and sit along with the book, so that you can see the question from there, because I will not be writing the questions, I will just be solving them for you. So the first question says, if a line makes 90 degree, 135 degree, 45 degree with the positive x, y and z axis respectively, find its direction cosines. So I need to find the direction cosines where angle is given. So it's very easy. You just need to find the cos of the angle, so I don't need to explain much, I've just done it. First thing what I did is, let L, M and N be the direction cosines of the line. These are the things you have to decide yourself, how you have to start. Okay, now L direction cosine, that is cos of 90, which is 0. M is cos of 135. I have done this here. It lies in the second quadrant. Cos is negative, so I put a negative sign, and that is minus 1 by square root of 2. Okay, similarly you can see for n we have cos 45, so we have square root 2, so this is the direction cosine. So it's very easy, you can do it. Now question number 2 says, find the direction cosine of the line which makes equal angle with the coordinate axis. Now we have coordinate axis like this. Okay, a line which is making equal angle. It's a line which is making equal angle here, here and here. So they are all equal. So what I did is, now they are talking about angles, so I took cos alpha, cos beta and cos gamma, direction cosine. So since it makes equal angle with the coordinate axis, all the angles are equal, so I put it as theta. Okay, now we know this L square plus m square plus n square equals to 1. Okay, so I have put this. Now if all the thetas are same, I will put theta 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 for all. That is 3 cos square theta, so 3 on that side. So you can say cos theta is equals to this. So direction cosines will be plus minus 1 by root 3 plus minus 1 by root 3 plus minus 1 by root 3. Okay, let's move on to question number 3. Now question number 3 says, if a line has direction ratios, so direction ratios are given to you as minus 18, 12 and minus 4. So these are the direction ratios given to you. So if the direction ratios are given to you, you don't have any problem. Okay, because to find PQ, we have already seen, to find PQ we did x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Okay, and what is x2 minus x1? X2 minus x1 is minus 18, which is already given. Y2 minus y1 is 12, which is already given. Z2 minus z1 is minus 4, which is already given. Okay, so now how do you find this PQ magnitude or the length of PQ? Simply minus 18 whole square plus 12 whole square plus minus 4 whole square. You find this, that will be your PQ, and then directly write 18 by that, 12 by that, minus 4 by that. So that will be your answer. Now let's move on to question number 4. So question number 4 says, show that the points this and this are collinear. So 3 points are given, this and this. We need to show they are collinear. So already I told you that to prove collinear, okay, now to prove collinear I will be proving a1 by a2 equals to b1 by b2 equals to c1 by c2, and I'll show that one point is common in that. So what do? I find the direction ratios of AB, then I will find BC. Okay, with B and C I'll find. So direction ratio of B, this one will be A1, this one will be B1, this one will be C1, A2, B2 and C2. Okay, so this is how we get. Okay, now we check, if you divide them you get minus 1 by 2 from all of them. Okay, that means they are equal. So if they are equal, that means they are parallel. If they are equal, that means they are parallel. But you can see that B is common in both of them. B is a common point, so I can say A, B, C are collinear. Okay, let's go to question number 5, the last question. So the question says, find the direction cosines of the sides of the triangle whose vertices are this and this, and also find the angle of the triangle. What type of triangle it is? So 3 things we are asked. First we need to find the direction cosines. Okay, direction cosines we need to find. Then we need to find the angles, that is, we need to find this angle, this angle, this angle. Okay, we need to find these angles, and then we have to say what kind of triangle it is, whether it is scalene triangle, whether it is equilateral triangle, whether it is isosceles triangle. So we need to tell them that. Okay, now we know how to find the angle between 2 lines. This we just now we have learned. Okay, so what do I do? Let the angles at the vertices, this one and this one, be angle A, angle B and angle C. So now what do? First thing, I find the direction ratios. Okay, so direction ratios of AB, how do I find? Direction ratios of AB, how do I find? These are x1, y1, z1, x2, y2, z2, because we are talking about a, b. Okay, b will come first, x2 minus x1. So you can see here what I did. You can look at the points. This is x2 minus 1 minus 3. Okay, 1 minus 5 and 2 minus 4. You can look at the points a and b. Okay, so I will get this as the direction ratios. Okay, to find the direction cosines, we need to divide by the magnitude. So I will find the magnitude also. Okay, now similarly you will find the direction ratios of the line BC. Okay, once you get the direction ratio of BC, then you can find the magnitude. Okay, why I'm finding magnitude? Because we will be finding direction cosines also. Okay, now you can see I'm finding all direction ratios first. So that the ratio of CA, I will find the magnitude. I'll find the magnitude of CA. Now after this, what you will be doing, finding the direction cosines. Okay, that is for you. You will be finding direction cosines. So direction cosines, how will you find? Direction cosines for, suppose, CA. Direction cosines for CA will be 8 by 2 root 42. The other one will be 10 by 2 root 42. The third one will be minus 2 by 2 root 42. So this is how you will write the direction cosines for CA, and then AB and BC you find out. Now you find the angle between. Now you look at the diagram. Angle B is between AB and BC. Okay, so I will be using AB. This one is A1, B1 and C1, and BC A2, B2, C2. Okay, so I have done here A1, A2 plus B1, B2 plus C1, C2 divided by square root of A1, A2, square root of A1 square plus B1 square plus C1 square. That, or you can directly write the magnitude which we have found. This is the magnitude of AB. You can see here. This is the magnitude of AB, and this is the magnitude of BC. So both I have written it here. You can see. Okay, so multiply them, you will get 4 by 17, and then this is cos of B. Okay, cos of B is this. So when you take cos on the other side, it will be equals to this. Now cos of A will be cos of A. You go to the figure. Cos of A, you see, is made by AB and AC. So you will use AB as A1, B1, C1, and this one is A1, B1 and C1. This one is A2, B2, B2, C2. Okay, and magnitude you have, I have written here, and the other one is 2 to 17. So I got cos A equals to, you can see, minus 21 by root minus root 21 by 34. Now you can see A is this. So similarly, you find out cos C. You will see that angles are same. So if two angles are same in a triangle, their opposite sides are equal. Okay, and sides opposite to equal angles are equal, so it is an isosceles triangle. Okay, so thank you. I'll be next we'll be doing straight line and planes. Okay, so till then you be thorough with this, and these should be in your fingertips. Very fast you should be able to realize what is going on. Thank you.